Hi everyone, in today's video we're going to have a look at design communication. So this is going to be most likely in paper 2, but aspects of it might well end up being in like a part B or part C of a question you might find in paper 1 potentially, but I'd say most likely it's going to come up in paper 2. So a couple of things to bear in mind. Communication, as in any industry, is absolutely key. Okay, so it doesn't just matter in the design and engineering world. Obviously, how you convey information to someone is through communication. There are lots of different ways to communicate with the people around you. There's just a few different things to consider while you're doing it. The first one being who you're communicating with. So it might be that you are a designer or an engineer talking to another designer or an engineer. So the way you communicate with them might be different from someone else. It might be that you are communicating with a client. So obviously then there might be other things that you need to consider when you're communicating with them. And then it might also be with outside businesses. So say if you are just one part of a project and you are doing a particular aspect of it, and then you need to take, so say for example you're doing technical drawing and then you're outsourcing the manufacturing of it, you've then got to make sure you can communicate correctly to the person doing the manufacturing of it. So it depends on who you're communicating with and sort of whereabouts in that sort of timeline or workflow rather, where you sit. And then there's also to do with what are you trying to communicate. So it might be to do with a specific design. So it could be, if say for designing with, like talking to another designer or an engineer, you may do like a quick sketch because it doesn't really matter. No one's going to see it. It's just going to be you just getting rough ideas down. Fine. It might be that there needs to be a lot more technical information. So say you are that designer or that engineer and you're trying to communicate key measurements in order for it to be manufactured. Obviously, those two, there's still two sketches or two technical drawings, but they're very, very different. Maybe that you're trying to communicate specific materials, components. Are you trying to get any key information across? That maybe like any data, any measurements, anything like that. And then potentially is it to advertise your product or your service. So it all comes down to who you are and who you're trying to communicate with, and then what are you trying to communicate to that person or that company. Okay, so hopefully by now you recognise British Standards 8888. So this is, as I've said before, you need to know who British Standards are, BSI, but you're never going to need to know, like off the top of your head, a certain standard, because that would be an incredibly mean sort of question you get in an exam and it just wouldn't happen. But the only one that I know off the top of my head is BS 8888 because it's to do with technical drawing. So the reason why I'm talking about this now is because this basically covers communication in engineering and in manufacturing. So what they will have inside this is, like, if you take like Fusion 360, so you've all done in your coursework, you come up with designs and then you've created technical drawings from that. The benefit, of course, from Fusion is that it will produce technical drawings from something you've already created. There are other softwares like AutoCAD where you have to do it manually, and then before that, if you want to get really old, so like when I was at university, is you had to draw them by hand on a drawing board. Excuse me. So one of the things you may have to consider is scales. Now this might be something you've had to do if you were doing, say, architecture, because obviously you cannot draw one-to-one scale, one being full size, because there's not paper big enough in the world to do that. Same if you're doing things like furniture. So you're always going to have to like consider what the scalings will be. So there are recommended scales that like standard ones that everyone uses. Okay, so 1-to-1, 1-to-2, so it's half size, and so on. So you don't just pick random ones out of thin air. There are selected scales that you're supposed to pick from, and those scales will always appear at the bottom right of the technical drawing as well. You'll also have first angle and third angle projection. So these are both different versions of doing what's called the orthographic drawing. So orthographic drawing, they both look very, very similar. But what you'll notice is, so basically what will happen is, this is where you'll have your 3D projection, and then in the middle of it, so that will be your plan. This is all 2D, and then you have side, front, top and bottom. And then the way, basically what will happen is that the sides that you have will be swapped round, and the top and the bottom will be swapped round. So which way are you looking at it from, for first angle and third angle projection? The most common one that we'll use in product design typically is the first angle, because typically if you imagine, I always say, like, imagine you've got your phone flat on the desk and essentially just roll it over. And you sort of like roll it as if it's rolling like roly-poly across the page, and then each time it reaches another side, you take a snapshot of that's the side that you draw. Engineers tend to use more about a third angle, but both are completely legitimate ways of doing it. It's just making sure that you know which way it is, and the symbol that will let you know which one is which is this symbol that you'll see down at the bottom. Okay, so you'll see that and it'll let you know that's third angle or that's first angle projection. So that is orthographic drawing. Again, a little bit more, just going into that so you can see the difference of it. But I have just explained that anyway, so we'll leave that on for a second and I'll move on. Okay, so with orthographic drawing, you are going to see something similar to this. Question is this a proper orthographic drawing? Okay, what is it showing us? What is it missing? Now I'm going to just be quiet for a couple of seconds. Can you have a look at that and see, do you think that's a correct one? Has it got everything it needs on there? What can you spot on there that makes it a technical drawing? Okay, so it's not an orthographic drawing, but it is a technical working drawing. So there's a few different things to look out for here. So what we've got is, when you've got this cross-hatching here, that is sectional views. That essentially means that object has been cut in for purposes of this drawing. That object has been cut in half so you can see the internal parts of it. And anytime you see cross-hatching, that's what that means. That means, okay, this object has been cut in half. You just have labelled parts lists. So we have all these balloons with the numbers, and then you have a parts list table down at the bottom. If you look down further down here as well, you've got things like your scale, so 1 to 5. You've got your third angle projection. So remember, that is third. So first would be, if you go back, so first and third. So in fact, sorry, that is first angle, my mistake. So that is first angle projection. So not a orthographic drawing, but still a technical working drawing. The thing that is missing from there to make it an orthographic drawing is having measurements on there. So what are working drawings in engineering and in designing and in architecture? Because they're all very, very similar. Okay, so the whole point of working drawings is to give, like working or technical drawings is to just convey information. Okay, and it's never going to just be like one particular page of drawings. They're probably going to be 4 or 5 different sheets of all the key information that you're going to find on there. Okay, typically they'll include mainly 2D drawings. You may get a 3D projection on there a little bit, but it's mainly going to be the 2D side of things. So what you're going to find on there are things like orthographic projection, key measurements you might have on there, your sectional views, your parts lists, your bills of material, and tells you what materials will be on there. And then when you might have the 3D one will be the exploded drawing. So if you picture that like when you get like a piece of IKEA furniture, and it sort of shows you all the parts and they're all in line but they're all exploded outwards, so you can see how it all goes together. Alright, now remember what I said is that these all come under working technical drawings. Okay, and you're probably going to have multiple different ones in like a set. There are certain things that they all need to be laid out the same way, so they have to include things like a title block. So a title block will be things like here. Now title blocks differ depending on what country you're in. Obviously we are in the UK, so we follow the British standards one. The US has different ones. The reason why it matters that these are consistent is because that's, people know what to expect and it's very clear, people know what to look for. There have been instances in the past where companies are working in different countries and working together, and because communication is not being completely clear, not entirely sure what units they're working in, not entirely sure like certain different things, and then things get messed up along the way. Okay, so it's really important that everything is really clear and they follow a set of rules. It's also important that information shouldn't be duplicated. So if you've got measurements of a certain part already in place on one drawing, you then shouldn't have that repeated on another page, because it can become confusing and it can be contradicting to something that's already on there. Okay, along with things like your scaling on there. And then also what you will have is things like line thicknesses. So we did go over, where's my mouse gone? There it is. So down at the bottom it's about line thicknesses here. So we talked about this in communication techniques at the start of the first year. Is it designers and engineers, we use thick and thin lines because it will highlight certain key aspects just so your eyes are drawn to that particular part of the drawing. So it stands out for you if there's any like key like features that are popping up off an object. So a couple of other examples that we talked about. So section views we've already mentioned. So the idea that you've got the cross hatching. So that is what will tell you, think cut in half, and it'll let you see any internal parts of an object. Exploded drawings. So as I said there, like IKEA furniture, the idea being everything will all just line back up again nice and easy. Nowadays these are all generated by CAD software for you relatively easily. As I said before, you did have to originally do this by hand and it would take forever. So then here's what you would say is like a proper orthographic sketch or working drawing. So this has got title block. So this is done to British standards, 8888. So you've got your third angle projection, the first angle, sorry, there. You've got things like scale is on there, sizes, materials, finishes. It has the name and everything on there. You got your border, which is all specific sizes on there, along with all key measurements, and everything is in line. So this is exactly what you'd expect to see on a technical drawing as part of a collection of other technical drawings as well. Okay, so that is the technical drawing side of things. Then there are other kinds of sketching, obviously, and we still all have places in the design and engineering world. It's just that you might not show freehand sketches to a client because that might just be how I communicate to the person in the office with me. It might be how you communicate to another student. It might be how you communicate to me. So those can be fun things like freehand sketching, which are really good because nice quick ideas, no specialist equipment, piece of paper, notepad, pencil, dead easy. To get really good at these, obviously it takes a lot of practice, particularly around like the fine art style sort of things. Not used so much to communicate ideas to clients, but as communicating to a fellow designer, absolutely. You've got isometric drawing. So this is drawn at 30 degrees. And I'm sure we're all seeing this isometric grid paper before. To begin with, once you're learning, that's what you use, but then eventually you remove the grid paper from there. Typically speaking, in 3D drawing or sketching terms, this is the style of drawing that most commonly used. The other one that people know about 3D drawing is oblique, which is sort of like you draw a face on and you drag it backwards. That's probably like when you first learned to draw in 3D, you probably did like a square and then you had another square just to the side of it at the back, and then you sort of like drawing the lines up. It is still 3D, obviously, but it's considered more like a primary school sort of drawing in 3D. You wouldn't really be using that in industry, and you'd probably just be doing isometric sketching. And you've got perspective drawing, so you've got 1 and 2 point perspective. This is used quite a lot in things like architecture because it gives you the whole idea of the sense of depth in your drawing, so like looking down the street and those sorts of things. So the idea being that you must always go back to the vanishing points depending on where you've drawn your object. So you've got mixed media and rendering. So this basically means you've used multiple different techniques in one sort of sketch. It might be that you've done sketching by hand and then you've used things like marker pens or watercolours, or it might well be that you have done your sketching and then you have texture rendered as in you've drawn the textures of your materials in there. So you may have drawn like the grain of wood in there or brick a lot more. Some people are a wizard when it comes to marker rendering. It's something I've never really gotten amazingly good at. It takes quite a lot of practice to get used to, but what the benefit being is you can really get the idea of the materials and you can sort of get the reflectiveness of it. So to master it is excellent. Like it's like some people are fantastic at it. It's not something I'd ever claim to be really good at myself. And and then text rendering, particularly using things like architecture because it will let you convey materials on buildings and those sorts of things, and it just becomes like drawing in grains, drawing in brickwork and that type of thing. So design reports. So we've sort of covered like technical drawing and like sketching and that sort of thing, but sometimes you need to communicate to shareholders, to bosses, to whoever it may be. So this is where you have to do like a design report, and it's kind of similar to how you do your coursework, to be honest with you. But essentially this is a record of a project that is left after the project's finished. So you've had a client, you've done your project, you've come up with technical drawings, you came up with the idea, you've produced the finished thing, it's been paid for, it's got off production, done. All right. But what the evidence of that at the end of it all will be the project report that's written at the end. So typically it's split into 3 parts. So it'll start with like an executive summary that's basically summarising the whole design, the whole project. The section 2 will introduce explains the design problem, the clients, the brief, that sort of thing. And then section 3 will be like known as your conclusion. It basically explains why you chose any designs that you chose, any problems you faced and how you overcame them, as you compare it to your specification, your brief, and how it might be improved. So it's kind of got some similarities to how you do your coursework, which is why that's sort of laid out the way it is. But it's just a very, very wordy document to show evidence of what they've done. So graphs, tables, and charts. So this is if you're trying to convey some sort of data to people. Okay, so numbers of some kind. So there's loads of different examples that you might do. So we've got bar charts and histograms. I'm hoping all of these are fairly familiar to you. We have covered bar charts and histograms in the math sections already. They do it's worth pointing out as well, they do like to use this for particularly things like anthropometric data to convey like sizes and measurements, that sort of thing. Bar graphs, pictograms, nice and easy to read. Not entirely accurate because you can't always tell is that 3/4 of something, is that half of something, and so on. Line graphs can show data over time, can show like things over time to see how things have improved or how they compare to something else. And then data tables, whereas it might just give you, here is a list of all the data, so it might be to do with measurements of a particular thing or battery life or handle length or whatever it may be, where it's just straight up, here's data, we don't need it communicated in a graph or a table, in a chart, here's just all the data, and typically that'll be used and then applied to whatever it is you're doing. So CAD modelling. So CAD, obviously computer design, is a very vague very broad sort of term now. So there's loads of different CAD packages that exist in the world. Obviously in college we use Fusion 360. The other major players in the world are things like SolidWorks, which is like the main one. You've got things like Rhino, SketchUp, which is a little bit sort of like primary school a little bit, but these will let you create like more technical, like technical drawings and functional things. You then have something that is typically referred to like as 3D modeling software. So you got CAD packages, so that is what I created this drill in, and then you got 3D software like Maya and Blender. So although they're still the same sort of thing that let you create a 3D object on a screen, the way you go about it is very, very different. This will be used a lot more in things where you're trying to get like advertising and promotion and like modeling sort of things. It's used a lot more in say like games, movies, because I can't go into theory without talking about F1. When Mercedes launched their 2022 car, they did like a promo and a render of it, and then they said that they created that in Blender, which I thought was incredibly cool. So the top right one here, I did that in Fusion, but down here I did that in Maya. You then do have, as well as having the modeling software and you can render it in there, you do have some software that is specifically for rendering, so things like Keyshot or Substance Painter. Well, that's actually the software's whole job there is just to add materials to it. Because if you look, Fusion, is okay at adding materials, but because there are some softwares that are specifically for adding materials, they are a lot more detailed, a lot more realistic. 3D modeling. So this is a really, really good way of basically communicating ideas in a more visual, hands-on approach. Because the idea being, obviously, you can have a sketch, but sometimes people can't always visualize it. So having a 3D model makes it a lot easier to like communicate your ideas in a 3D way, because you can sort of feel models, you can have a look at different angles, those sort of things. Now, easy, relatively quick-ish, it says. So modeling material can vary from like things like just cardboard to modeling foam. Modeling foam is used a lot because literally if you get like the denser stuff, you can cut and sand it and paint it to be like the real thing. In fact, a lot of props in like movies and those sorts of things will all be made out of modeling foam. So something that looks super heavy, you pick it up, it weighs like nothing. And then obviously you've got like 3D printing nowadays, where it's called rapid prototyping. It's not really rapid because sometimes it can take like 12 hours to print something, but it's still a really good way of communicating something to another designer or to a client or to a focus group. So you also have like things like annotations. So how do you annotate your designs? And again, this is probably going to be before you show things to a client, because this is how you're going to communicate to your bosses, your fellow colleagues, those sorts of things. So talking about materials, manufacturing, positives, negatives, improvements, those sorts of things. So you can sort of see the kind of thing. So you have your design, you sort of annotate coming off, so you can sort of like think. Basically, this is like your thought process. So here's the design, here's what I'm thinking. As you get further down the process, obviously you'll start answering these questions yourself a bit more, and you start removing the annotations, because you'll just have the final design, and you'll know all this eventually will be conveyed in your technical drawings. Okay, and then finally, a few other additional techniques. You've got things like digital photography, typically used in graphics, where they use like graphics tablets and things. So you do a lot more promotion. You can do layers like Photoshop. It's like layer on top of things and get a lot more like crisper look to it. And then cut and paste techniques, which is just the technical name for like mood boards, which everyone knows mood boards. It's just collages of information to sort of give you inspiration and ideas for anything you want to do. Okay, so little task for you. What I'd like to do is come up with a simple design for a piece of lighting. What I'd like to do is use as many of the communication techniques we've talked about in the video to communicate that design. So I don't need a lot to give me one design, and I want you to try and use as many of those different communication techniques as possible to convey that design across. That is the end of design communication. Got any questions, let me know and I'll get back to you.